Hi, this is Suey778 coming at you, and today on the channel I have a new mini bench multimeter to review and test. This is none other than the Owon XDM1041. So let's get right into it. This is available for around $125 to $150 US. It depends on where you get it. I got mine on eBay for around 125 bucks, I think. You can also get this on AliExpress or Banggood or even Amazon. Prices do vary, so your mileage will vary, as they say. I'm not going to do an unboxing on this. I'm just going to show you what you get in the box. So first of all, you get an RS-232 cable, a set of leads. You also get an IEC cable, which I already have out, but I'll show it right here. You also get a spare fuse. It comes in a bag here. I don't know if you can see that or not, but yeah, there's a spare fuse right there. Trust me, it's in there. There it is right there. I'm assuming that's for the power supply. Also get a pair of alligator clip adapters for the leads. And you also get a nicely printed out spec sheet that I can just hold up to the screen, and that way you can read it. There you go. And last but not least, you do not get a manual with this, but you do get a quick start guide. So that's nice. It will get you going, and that's basically it. Now, there are a couple of variations of this. You did notice me holding up the RS-232 serial cable. This is the RS-232 version, as you can see right here, and then your IEC power is right here. This does come apart. I'm not going to do I'm not going to take it down because it's already been done in another video. I've actually had this meter for about 4 months. I've been trying to get to it. I've just been too busy. Like I said, I kind of had to suspend operations on my channel for a few months, but we're back. So we're going to go ahead and do it anyway. Do the review, that is. This unit does have firmware version 1.1, which is, I think, the original version. I think it's up to version 1.3. Actually, I think the latest version just has a date on it. But Owon doesn't really seem to make it easily available, which is kind of strange. I think you actually have to contact them to get it. And the other thing about it is that the firmware really doesn't update anything that anybody has been able to decipher anyway. So we'll get into that a little bit later. And that's pretty much going to do it for the opening. So let's go ahead and get to the overview, and we'll go through the features of this. Okay, now for a quick overview of the Owon XDM1041. As you can see, this is a 55,000 count meter. It's got a nice TFT full color display. You've got your soft key buttons here, AC/DC voltage button, AC/DC current button, continuity diodes and resistance button, your power button, capacitance button, frequency button, temperature button. Your run and your stop. This is basically just a fancy way of saying hold, and it's just freeze frame hold. Your record button, your utility button, your math, which will show you stuff like maximum and minimum, and there's one other thing that it shows. I can't remember what it is right off the top of my head. We'll look at it here. Your dual display settings. This works. This mostly is going to be used for AC voltage and AC current. Got your range button, up and down buttons, your common jack, your measurement jack, for voltage, resistance, capacitance, etc., etc. Your microamps and milliamps connection for up to 600 milliamps, and then your 10 amp connection. Both of these are fused. This is being touted as a category 1 1000 volt or a category 2 600 volt. That's pretty believable, I think. Let's go ahead and turn this on. Takes about 5 to 7 seconds to boot up, so that's fairly quick. First thing you want to do when you turn it on is go into Utility to do your setup. Now the first thing that you might find when you go into this is that everything might be in Chinese, but if that's the case, just hit this top button and that'll throw you right into English. As you can see here, we have the model, which says mode, but it's actually the model. The version, firmware version, which I have kind of an older version. The firmware updates are not really readily available from Owon. I think you actually have to contact them and ask them for it, although I don't know if it's really worth it to update the firmware, because from what I've heard, the firmware updates really don't do much of anything. You get your serial number, checksum number. You get the 5 levels of backlighting, so you get 0%, 25, 50, 75, and 100. This is your clock setting right here, the RTC. You want to hit your set button here, and then you can use the range button to scroll here. We're not going to do anything, but I'll just show you just to change that real quick. And then once you have it the way you want it, you click on OK, and you want to hit your back button. The next is for the default settings, and this basically put everything back in the default, whatever it was. That might put it back in the Chinese. I don't know. Let's find out. I guess not. Maybe it does default to English. Okay, moving on here on the utilities. Basically just your settings for your RS-232 connection, your baud rate, parity, stop bits, and data bits. And that's basically it. Okay, so let's go into more on these soft keys here when you're actually in there taking measurements. Here's your range button. You can set it to auto or set it to any level that you want. Like I say, if you put it in manual and then to put it back into auto, you just select the auto. Very simple. It's like this for pretty much anything. All the ranges, you know, for all your functions. The scan speed, low, mid, and high. My recommendation for this would probably be to run it either in low or mid, because in the high settings I've noticed the accuracy tends to suffer a little bit. I think the sweet spot on this meter is basically the mid setting. And then your function. In this case we're in DC voltage, so you will have voltage and millivoltage. If you switch over to ACV, the same thing here. Voltage and millivoltage. We'll leave it in millivoltage just so we're getting some numbers here. Now that brings up the next thing, the dual display. So when you hit that, it's going to give you an option for a dual display. It's fairly basic. You get a frequency reading along with your voltage reading. And then of course if you want to get the duty cycle, you'll actually have to go to the frequency setting. And it'll give you the duty cycle, which we're probably not going to get anything here. Nope, we're not. So anyway, back into AC voltage. Let's go back into the dual. Again, hit the frequency. So that's how you do that. And then basically to get out of it, basically just hit your exit button. You have a couple other things here, your math. And you can do your max min. And we have to turn the display on to display it, so it gives you your maximum, minimum, and average. Pretty simple. And of course you can clear it out. So that's kind of cool. I like that. Straightforward. And then of course you have your dB and dBm settings. Again, this is showing well, okay, there we go. I'm sorry, I did that wrong. So your dB and dBm settings, basically you can, you toggle between them. That gives you your decibel measurements on AC. And of course, to go back, you can turn it on and off. Turn it on, off. Okay. So that's basically it. We'll get into the record function later. And like I said, the run stop is just a hold feature, and that's all it is. There is no auto hold on this, and that's pretty much it for the features. RS-232 connector is on the back. It does come with the serial cable, as I showed in the pseudo unboxing. And the data function, of course, can record up to 1,000 points. We'll get into more details into that later. But for right now, we're not going to do a teardown of this. It's been done on other videos, and I'm just not going to bother with that. So let's go ahead and get to some measurements here. Okay, here we go on the DMM Check Plus test. We're going to start off with the DC voltage. This should be 5.00 volts. And we are getting 4.9986 volts, so not too far off. Slightly low, but not much. All right, let's switch over to AC. And on AC, we should be getting 4.9999, and we are getting 4.986.3. So again, pretty decent. Okay, let's go ahead and check the hertz and the duty cycle. It is coming in as 100% and 50% duty cycle, so it should be 49.98 and 100 hertz plus a bunch of decimals, but it is reading it properly in that scale. Okay, next up we're going to do the resistance here, so let's go ahead and try that. This first one is 100 ohms, should read as 99.99, and we are getting, let's put that in mid speed there so it'll read a little bit quicker. We are getting a 100.0708, pretty good. All right, let's go to 1K, and this should be 1.0005, and this is reading it as, it's settling a little bit, but 1.0009, again, very, very close. I'll take that. Okay, 10K, this should be 10.0044 kilo ohms, and this is showing it as 10.006, so not too bad. All right, pretty close again. And finally 100K, and this should be 100.064, and the Owon is reading it as 100.07. So again, very close, did very well on the resistance. In fact, it's almost right on. All right, and that's just me touching the leads. Okay, as you can see, we got some new stuff in here. This is the LC daughterboard. We are going to do a review on this and also give a little instructional video on how to install this. There's really not much to it. Anyway, let's go ahead and go to the capacitors here, since we do have some 4-precision capacitors here. The first one is going to be basically a 992 picofarad. So let's go ahead and try that. And this should read as, like I said, 992 picofarads. So let's see how this does. And the Owon is reading it as 0.98 nanofarads, so I would say that's pretty good. All right, let's go to the next one. Next one should be 10.1 nanofarads, roughly. And this one is reading it as 10.09 or 10.08 nanofarads, so pretty good, pretty close. All right. Next up, we have a 100.6 nanofarad. And the XDM1041 is reading it as 100.7. Again, very, very close. Nice. And last but not least, we got a 1 microfarad. This should be 1.007 microfarads, and we are getting, as soon as it ranges here, 1.028 microfarads. So again, very, very close, no problem there. So looks good there. Okay, next up we're going to do the current test, and this should be, we're going to start off with DC here. Let's make sure we're on DC. Yep. Let's put this in the correct mode here. Yep, the milliamp mode. This does not have a microamp range, but we're just gonna run with it. So this is DC. This should be 0.9996 milliamps, and it is reading it as 0.9995 milliamps. So very, very good. All right, let's switch over to the AC. See how it does there. And on AC, we're getting 99.69 milliamps. Or I should say 0.9969 milliamps. The actual reading should be 1.001 milliamps. So not too shabby. I would say this did pretty well on the current test. Okay, so here we go with the AD584, the analog devices voltage test. We're going to start off with 2.5 amps, so let's go ahead and get our plugs plugged in here and see what we get. And we're getting 2.5006 on the UNI-T and 2.4997, so not too bad there on the Owon. All right, let's go to 5 volts. Getting our customary 5.055 volts on the UNI-T and 5.0038 on the XDM1041. Again, pretty darn good. All right, 7.5. Our regular 7.502 average on the UNI-T, and the Owon is reading it as 7.501. Again, very, very close. And 10 volts. Regular 10007 on the UNI-T and 10.005 on the Owon, so pretty good there. Let's go ahead and try with the power supply. 32 volts. Hopefully I can make these reach, so bear with me just a second here. All right, so here is 32 volts, and we are getting 32.004 on the UNI-T with a high voltage indicator, and the Owon is reading it as 32.001, we'll call it. So again, very, very good. So this thing is quite decent on DC voltage. Okay, and as you see here, we got a new toy for the current test. Now this does have a range. This is the Fnirsi SG-003A. I'll probably do a review of this at some point, but we have an output range of 4 milliamps up to 20 milliamps. So we're going to do a few more tests. This basically is going to replace the light test that I used to do. This is just a lot more consistent. I've had this on, so this should be relatively stable at this point. So we're going to start off with 4 milliamps. So let's turn her on. And we are getting 4.0081 milliamps. And that's about what I was expecting with this box. I have played around with this some, so yes, that is an accurate reading. All right, let's take her up to, let's go to, let's try 7. Okay. And that is 7 milliamps, and it is reading it as 7.01 milliamps. So again, that's just about right. Let's go ahead and take it up to 10 milliamps. And we're getting 10.021, which is right around what I was expecting it to read. So that's good. Let's go to 15. And that is reading as 15.031. Again, very, very good. And last but not least, we'll go all the way up to 20. And 20.038. So I would say on current, this is doing quite well. Very good for voltage and current, the Owon is. Okay, and now we're going to move on to some of the other tests. Okay, now with these leads, I'm not sure whether these covers come off or not. They do not want to come off though if they're detachable, so we're just going to have to test the continuity with them like this. Not ideal. but they seem to be pretty good. Yeah, let's see what we're getting. Are we getting any kind of yeah, see, it's hard to keep contact on this. Yeah, it's coming down. I mean, they're okay. I just, oh man, I tell you, I've spent 5 minutes trying to get these stupid things off and these covers off, and I'm not sure that they come off. I've never had so many. Yeah, boy, that's okay. Anyway, let's go back to what we're going to test with anyhow, which are the probe masters. Let me get these patched in and we'll do a continuity test on these. As you can hear, it's got a nice loud continuity beep, so yeah, no mistaking when you got it. Alright, here are the probe masters. Yeah, down to 0.1 ohms, good there. Yeah, absolutely no problem. Okay, so that will do it for continuity. Looks good there. Alright, and one other thing I'm going to do here is actually, let's go ahead and I want to test the output voltage of the diodes for this. Let's turn this beeper off because it'll just go crazy. I'm going to test it with the with my UNI-T UT8804N. Let's see what we get here. So the output voltage on this unit on diodes is a very healthy 3.2515, so it looks good there. Okay, so here we go with the rest of the test. We're going to start off with the diodes. Up first will be the LEDs, so let's go ahead and do that. Let's make sure we've got it actually in the LEDs, which I don't think we do. Okay, we're on the diodes. Now you want to turn the beeper off. I'll turn it on just to show you, because when you measure anything, like when we measure diodes here, look at this. Yeah, it'll just stay on, so that's no good. So we're going to turn that beeper off, as you can see there. Alright, so let's go ahead and go with the LEDs here. So we get red with a reading. Alright, yellow with a reading. Okay, get green with a reading, blue with a reading. These readings are a little bit high, by the way, but not bad. And white with a reading. All right, let's go ahead and do the RGB real quick. Got red with a reading, green with a reading, and blue with a reading. Okay, so no problem there. Let's go to the diodes. Here is the rectifier. .5063, kind of low. Okay. Fast recovery. .478, again, pretty low. Okay, here's the Schottky. .170, yeah, that's also pretty low. Okay, here's the switching. Yep, again, low. That's about 50 counts low right there. And the germanium, this should be .280 to .290 somewhere in it. Yeah, it's reading as .251. So, yeah, kind of low. Not that thrilled about that. Alright, so let's go ahead and measure some more resistors. I'm just going to get the substitution box for this. So put this aside and get that out. Okay, let me get the, make sure everything's off here. Let's get it into resistance, that would help. Okay. Alright, so we're gonna, as you can see, we do have the customary onboard resistance with nothing engaged, so we can rail that out. And there you go. Alright, here's 1 ohm. Looks pretty good there. All right, let's try 10 ohms. Looks good there. 100. Looks good there. And I'll go to 400. Looks good there. All right. Actually, we'll try 600. Looks good there. Okay, that's 1K. Okay, looks pretty good there. All right, let's go to 10. Looks good there. 100. Good there. 1 meg. A little bit high. Okay. 2 meg. Yeah, that's about right. Okay, 4 meg. Yep, that's right on. All right, let's go to 10. Slightly high, but not bad. I'll take that. And we're finally 11 here. Sorry, I was trying to adjust the camera a little bit. And again, reading it as 11, slightly high. But yeah, overall, this thing is actually pretty good on resistance. I don't have any problems with it. All right, let's go on to capacitance. And I'm here to warn you, this is where we're going to have some problems, folks. So let's go ahead and switch over to that. Let's get these patched up here real quick. Okay. So we're going to first try 100 picofarads. And it is not reading it. And that's a shame. Well, we are in caps, right? Yeah. All right, let's try 150. Nothing. 220. Nothing. 330. Nothing. 470. Nothing. Why are we not getting it? Ah, there we go. Okay, so this is 560. It's reading as 520, a little bit low, which is what it should be. It's a little bit lower, but that's all right. 680. This should also be low. Yeah, that looks okay. 820 should be around 800. Yeah, it's kind of low. Okay, 1 nanofarad. That's actually not bad. 1.5 should be a little bit low, and it is. 2.2. That's about right. 3.3. This should be low, and it looks like it is. All right, let's switch over to the higher side of the box here. This should be 4.7. That's just about right. Okay, 5.6. This should be a little bit low, and it is. 0.68. Same deal with that. It should be about 0.6, 6.4, 6.3. Yeah, that's fine. 8.2 should be a little bit low, and it is. In fact, that's falling right just about where it should. Okay, here's 10 nanofarads, and yep, that's just about right on. 15 should be a little bit high, and it is. Okay, 22 should be about right on, and it is. 33 should be a little bit high, like around 34-ish. Yep, good there. 47 nanofarads again should be around 49, and it is. This should be a little bit low, 56, around 54, and it is. 68 nanofarads. Yep, about 64.7. That's pretty close. And this should be reading about 102, 103 nanofarads, although it's supposed to be 100. And it's reading it as 103.3, 103.4. So it looks good on the small ranges. So yeah, I have absolutely no problems with this thing on the small ranges. But we are going to run into some problems with these higher value capacitors. So let me get my test board back over here, and we'll show you, and I'll show you what I mean. And this is kind of unfortunate, but Get that lined up there. Okay, so first of all, we'll do a check on this little 85 nanofarad, and we're going to leave it in auto ranging. The auto ranging on this thing is, well, you'll see. All right, that's about right. Let's go to 1 nanofarad, or 1 microfarad, I'm sorry. Yeah, that's about right. Let's go to 10. If I could get my probes on it. There we go. As you see, it's getting the higher values we get, the slower it gets. Come on. All right, let's try it. There we go. Sorry about that. It's because I'm having trouble seeing the holes. I'm kind of at a weird angle here. Okay, that's right. But as you see, let's try the 47. This should be more like around 44, but you will see that this is going to get slower and slower and slower on the auto ranger, and also dumber. Okay, it did read that right. All right. Well, no, actually, it's still ranging. I'm sorry, it fooled me. See, it's trying to go to, yeah, 5 microfarad range. See, it's trying to auto range, and it's just having a lot of trouble doing it. Okay, now it's in the correct range there. Okay, that is a correct reading. Good God. That's not good, folks. All right, let's try 100. Okay, this one it seems to be doing a little bit better with, but again, just look how slow it's taking it to just range correctly. Okay, and it is getting correct readings. Now, I'm not knocking it too much here, but yeah, all right. So when we go to 1,000, what's going to happen? Well, let's see what happens. You're not going to like it. As you see, it's trying to range, still trying to range, still trying to range. Okay, we're finally in the correct one. See, and then it dropped back down to microfarads again. Okay, now we're into millifarads, which, okay, and there is the reading, which is good. That is an accurate reading. But did you see how long it took to get to that? Oh, wow. Not good. All right, we'll try the 2200 if I can get her to work today. Yeah, it's not playing nice with me. Come on. Come on, baby. There we go. This is going to take even longer. And the other thing about this is that you're going to start seeing like little artifacts and stuff appear on the screen. Haven't seen it yet. It's probably not going to do it now that I'm filming it. Yep, see? Jumped up there. Okay, it actually got to that one a little bit better. Yep, there we go. That's what I was talking about. Saw that little artifact appear. All right, let's try the big one. But as you can see, the auto ranging makes measuring larger value capacitors on this thing excruciatingly slow. As you can see, it's like going through the ranges and doing all that stuff. And I hate to say it, but that's a real shame. It really is. Okay, and we are kind of getting there. It's measuring that. There we go. That's more the correct reading. Okay, yeah, that's about right. So again, it is accurate, relatively accurate, but yes, it is slow, as you can see. And even if we put this in manual range, let me put this in, we'll put it in the 5 millifarad range, and we'll try measuring we'll just do the 1000 microfarad again. Let's see what it gets. But as you can see, now see that one, it measured it okay. Yeah, you know, so that is one workaround to it, but it doesn't always work quite that way. Let's try the 2200 again. Hopefully it'll play nice. As you can see, it's doing some more weird stuff there. It is trying to measure it. Yeah, you see all that crap that just comes in there? It's like, you know, what the heck is that? So as you can see, manual range is not without its issues either. Now that reading is correct. But as you can see, it's just doing all kinds of weird stuff. So I don't know what Owon was thinking when they did this, but yeah, that's pretty bad. In fact, I would have to say the auto ranging on this and even the manual ranging to some extent basically has gone full retard on this unit. I don't like it. It's accurate, but I don't like how it's implemented. Okay, here's a quick test of the AC outlets measurements. So we'll check the frequency and the voltage. So first we're going to do the voltage here. Let me get those in. And it is reading it as 122.57. Just to show some of the dual display here. Well, there we go. I'll show the frequency there. There we go. So as you can see, it's displaying the frequency, which is 59.981 hertz. And then, of course, to get the duty cycle, let's switch over to the actual frequency setting. And that is showing it as, yep, 59.991, kind of wavering around a bit. And the duty cycle is showing as 51.1%, 50.3%. So moving around. And it takes a little bit to settle, but once it settles, it looks like it holds pretty true. So I would say that works. Okay, and here we go with the Thermoprobe test. Now, since this thing does not come with thermoprobes, I borrowed some from the UT UT8804N. This does have 3 modes of temperature displays. You get Celsius, Fahrenheit, and Kelvin. So that's kind of cool. We're going to go ahead and put this in Fahrenheit, and I can tell you right now that this temperature is not correct. It's reading it as 70.4 degrees, and my overhead thermometer, which I know to be accurate, is showing 75 degrees. So, as reported in other videos, yeah, this has some issues on its accuracy too. But let's go ahead and try the fire test. Well, let's try the body heat test first. Let's see if it reacts. Yep, okay, it goes up. And yeah, again, it's measuring it kind of low. We'll hold it here for a minute to see if it, yeah, see, that should be, reporting more like, yeah, more like, in the low 90s, mid 90s. All right, let's see how far it drops down. Let's go ahead and give it the fire test. Let's see what happens. Does seem to work, and it is fairly fast reacting, but honestly, I don't know how accurate this is because, like I said, it may just be that it's more designed for, enclosed environments, where you're sticking it into something like, like water or, an oven or something like that. And not so much with ambient temperature, but it does seem to be reactive. It does seem to be functional, but as far as the actual accuracy goes, well, like I said, it's dropping down here, but it should drop only down to 75 5 degrees, and it's probably going to drop below that here. Let's see how far this goes down. I'm hoping it'll. Yep. See, yeah. See, it's not even slowing down. So I bet you this is going to fall below 75. And well, actually, yeah. See, it's still dropping. Yeah, so I would say it's not very good at measuring ambient temperature, and I know this Thermoprobe is good because it recorded the ambient temperature accurately on the UNI-T. So anyway, there you go. There's the Thermoprobe feature. Okay, here we go with the frequency test for the Owon XDM1041. Now, according to the manual, this can read from 10 hertz all the way up to 60 megahertz. The stipulation being that reading at 60 mega or above 10 megahertz, you need at least a 3 volt amplitude. I've got it set to 5, so we'll see how high it can really go. So let's go ahead and turn it on. I've got it set at 10. I tried below 10. It does not like reading below 10 very well, so we're just going to start at 10. So let me turn this on. Okay, and we're getting 9.995 hertz there. It is still wavering around a little bit, but generally, that's okay. All right, let's go up to 100 hertz. Okay, whoops, got it at 90. Try 100 there. Okay, and that is going to read it as 100 hertz, 99.999. All right, yep, getting more stable. Let's try 1K. And 1K is coming in as 999.96 hertz. All right, looks pretty good there. Okay, let's go to 10K. Kind of slow on acquisition, but yeah, 9.9996 kilohertz looks pretty good there. Nice and stable. All right, let's go to 100K. 99.996 kilohertz. Okay, let's go to 1 meg. And we are getting 999.96 kilohertz. Okay, so it looks pretty good there. All right, let's go to 5 megahertz. And we are getting 4.998 megahertz. 9998, I should say. Yep, good there. Duty cycle is still good too. All right, let's go to 10. And I suspect this is the actual designated ceiling of this, because I can tell you right now, this is not going to make it to 60 megahertz. All right, let's go ahead and go to 20. And it is reading that as 19.999 megahertz. Okay. All right, so let's go to 25. And again, this is on a sine wave with an amplitude of 5 volts. It's reading that just fine. Okay. The duty cycle looks okay. It's not super, but it's okay. All right, let's go to 26. It's reading that. All right, let's go to 27. And it's kind of reading that. I guess we could give that a pass, 27 megahertz. But as you can see, we're starting to lose it. I mean, it is gradually catching up to it. Kind of slow though. But yeah, I'd give that 27. I'll give it to it. Let's go to 28. And at that point, yeah. Well, as you can see, the duty cycle just went completely south there. I mean, it's trying to range to it, but well, I mean, we'll see. It's like it's trying to compensate to read it, which is weird. And it actually is going to make it. Well, maybe. Yeah, it's not going to be able to read it. So it looks like its upper limit is actually 27. That's a little bit disappointing because the specs do say it's supposed to go up to 60 megahertz. Well, I think we just confirmed that it cannot. Okay, now I'm going to show you the recording functions of the XDM1041. These are pretty rudimentary, but you do get a couple of options. As you can see here, I've got my power supply feeding some voltage to the meter, just so we can get some recordings on stuff. So to get into the record mode, you hit the record button, and you have two options here, manual and auto. We're going to go to manual first. And as you can see, what you can do here is just hit your manual and it'll save it. As you see, we got some records coming up here. And that's cool, I guess. And it'll keep appending on. You have up to 1,000 points of records here. And then of course you can clear them. So you just hit the clear, clears it out, and then you can start saving them again. The only bad thing the thing that I don't like about this though is, see, you can't, you see your readings, but you can't see the actual real-time reading when you're in this mode. That kind of sucks, I think. All right, so we're going to keep these 8 records. So let's go back and let's go into auto. Now with auto, you can define how many points you want, and the way to do that is to hit this button here. Use the range button to scroll over. We're going to do, well, let's just keep it at 5. Right now I've got it set for 5 points, and we're going to do intervals of 1 second. So you would think that this is going to add it in slot 9 and keep going down, right? Well, let's find out what happens here. So it's recording it. It doesn't even show it while it's doing it. And as you can see, it overwrites the entire thing. Okay? Well, maybe because the other ones were manuals. All right, so let's try something even different here. Let's change this to 3 points, and let's see if we get 3 appended on the end of that record. Okay? Same interval, 1 second. Hit start. Nope. Completely overwrites it. So while this does do auto mode, and you can set a lot of things, whatever, you can set up to like 9,999 second intervals, or as little as I think like 15 milliseconds or something like that. It's a pretty small interval. It's going to completely overwrite the file every time. When you're manually recording, it's fine. It will keep appending on the end. So that's a little bit weird. I would say if you really seriously want to record data with this, you would probably be better off using the software. That's what I would do. Onboard, in a pinch it'll work, but I don't know. It's all right, I guess. It's not as nice as my UNI-T is, though. But there you go. There are your record features. Okay, and that's going to bring me to the pros and the cons of this unit. First, the pros. It's got very good accuracy on most readings, and a very nice, sharp, full color display. I like this display a lot. It's nice. Have no problems with it. Shows a lot of information, and it's fairly easy to get the secondary displays for the most part. It's got solid build quality, at least on the outside. On the inside, I'm not sure. I think there is some suspicious thought about the power supply. Like I said, I'll have to open it up at some point and see what the deal is with that, but I'm not doing that today. It comes with usable leads, although I don't know why I couldn't get these tops off. I guess I'm going to have to get a pair of pliers or something. But when I did test it for continuity, what I was able to do, it's fine. These leads are usable as is. You don't necessarily need probe masters to get started with this thing. So yeah, decent leads. Records up to 1,000 points of data on board, which is always a nice feature to have. And a sensible menu system. I found this thing very easy to navigate. No big deal. And last but not least, this thing is tiny. I mean, it's very compact for a a bench multimeter. I would definitely recommend getting this over an Anning AN888S or 999S because it's smaller, it's probably more accurate for the most part, and I don't know, just easier to move around. That's what attracted me to this, because mainly I needed something that had an always-on display that I could put anywhere, you know, for voltage measurements and stuff like that. Okay, now on to the cons. Unfortunately, there are a few. Measures diodes too low. There's really no other way to slice it. Whether that's going to be a problem for you or not is really going to depend on, you know, the level of precision that you need. Some people probably could get by with it, others maybe not so much. Secondly, the auto ranging on capacitance is absolutely atrocious, and the capacitance mode in general is glitchy and weird and kind of dumb, and Owon, you just need to rethink that whole thing. The capacitance readings are accurate. That's fine. That's not the problem. The problem is that it just doesn't work very well otherwise. And that's all I'll say about that. You do not get software or a manual. You have to download them from the Owon site. It at least does come with a quick start guide and a spec sheet though, so enough to get you going, but it would have been nice had we had a print manual. That's always nice to have. Another con is that no data files can be saved on board. You're basically stuck with a single file, especially in the auto mode. It will overwrite it, period. It does not append to anything. Now you can append when you're doing manual recordings. It will append up to a 1000, but it will not do it in auto mode. And quite frankly, not being able to save separate files or, you know, or put divisions in the master file, that sucks. I'm sorry, I don't like it. The manual is not translated to English as well as it could have been. I was reading some stuff there and I was just like, I had to laugh. It could be confusing to some people, so they could have done a better job with that. And lastly, about the firmware. Although there are new firmware versions, newer than mine, the word out on the street is that it does not address the issues with the capacitance mode. So I'm not even going to bother. I mean, you know, there's no improvement to that, then why go through all the trouble of doing the firmware? And the firmware is a difficult process from what I can see, complicated. Plus you have to, you know, twist Owon's arm to even get the firmware updates. So yeah, don't like that. Okay, and that brings me to the conclusion. The Owon XDM1041 is an attractively space-saving bench meter with a very nice full-color display that has great accuracy on most measurements and hosts all the features that are suitable for use on an electronics bench. The user interface is generally easy to get around, and the display can show secondary information in certain modes and employs simple and effective math features. This meter is not without its shortcomings, however. The diode readings come in too low and may be undesirable to those who need precision on such measurements. The capacitance function, while accurate on readings, is terrible on auto ranging, especially when trying to measure higher value capacitors. I would personally say I would use manual ranging in that mode on anything above 100 microfarads and maybe even above 50. To avoid those issues. Even so, using manual range doesn't always solve the glitchiness, so be aware it's not going to be a complete workaround. Now, they have attempted to update the firmware to correct the issues, but from what I have seen, it hasn't fixed anything, at least so far. Otherwise, this DMM would probably fit the bill for most people, assuming that they can put up with the quirks with the diode and the capacitance modes. And this especially would be useful in the role of a secondary meter with an always-on display for doing things like monitoring voltage, which is what I typically use this for and what I got this for. So I'm happy with it because it's doing what I need it to do. The bottom line, well, to be perfectly honest, I have mixed feelings about this multimeter. It is really good in a lot of areas, but in other areas it just falls short. If the XDM1041 is being purchased to be used as a secondary meter, I could recommend it. I could give it a thumbs up for that. However, I cannot recommend buying it for the role of a primary meter. There are just better options out there. And I would say, quite honestly, save your money and get something else. Like maybe my little UNI-T back here. It's flat out a better meter than this one is. Hopefully Owon will get these problems corrected in the future. But overall, like I said, as a secondary meter, yeah, I like it. And there's a lot to like about this. It's just unfortunately there's some stuff not to like so much about it. But that's pretty much going to do it for me. So I can't give this a thumbs up or a thumbs down. I'm just going to say it's going to depend on your needs whether it's going to be a good buy for you or not. But that's going to do it for me. This is Sui778. Thanks for watching, and we'll see you on the next one.